Good morning, everybody. My name is Dr. Travis Van Leeuwen. I'm a research associate here at the Cape Eleuthera Institute. Although relatively new here to the CEI, I've got several projects on the go at the moment, ranging from the movement of bonefish to help identify spawning aggregations, to plastics work, to also the movement patterns of pelagic species here in the Exuma Sound.
Good morning. My name is Cameron Ragoose. I am a research fellow with the Island School, and along with Travis, we have had the distinct pleasure and privilege of advising this semester's marine debris team. So without further ado, I would like to pass it off to our team.
Good morning, everyone. Thank you so much for being here. This is the Marine Debris Research Team. I'm Kira Hall.
I'm Kit Shaw.
I'm Isla Van Dusen. I'm Isabella Brown.
I'm Sam Terrence.
I'm Gabby Noah.
And this is Quantifying Plastic and its Biological Impact in the Exuma Sound. So, I'd like to start off by asking how many of you have been to the beach since being here? So, of those who raised their hand, how many of you noticed or observed plastic on the beaches? Yeah, so I'd just like to point out that the vast majority of the plastic that you saw washed up on shore from the oceans. So just to give you an idea, 72% of the Earth's surface is covered by oceans. And due to the rise in large-scale plastic production, there's been a rise and accumulation of plastic in the ocean waters as well. To be more specific, calculated in 2010, 4.8 to 12.7 million metric tons of plastic were dumped into the water. So this graph shows the world plastics production over a 100-year span. On the y-axis, we have the amount of plastic produced in millions of tons, and then on the x-axis, we have years. So as you can tell, over time, there's been a drastic increase in the plastic production, comparing the low number in 1950 to the huge prediction for 2050. In 2050, it's predicted that 380 million tons of plastic are going to be produced in the world. So if you think back to the plastic that you saw on the beaches, think about just how much more plastic you'll see in 2050. Because this is a relatively new pressing issue, research and studies are very limited.
Though there are limited amounts of studies that have been done to help quantify the global scale impact of plastic pollution, existing studies have shown us a few things. For example, plastics have been found to come from three main sources. Now, these are recreational ships, fishing vessels, as well as normal everyday beachgoers. In addition, studies have shown that plastics typically enter the ocean as macroplastics. Now, these are pieces of plastic that are larger than 5 millimeters that can photodegrade down into thousands of microplastics. Take this cup, for example, on the left-hand side. This piece of macroplastic can photodegrade down, or in other words, be damaged by the ultraviolet rays and heat of the sun and turn into thousands of microplastics, as seen on the bottom here, that can easily disperse throughout our oceans. In addition, plastics have been found to have both physical and chemical effects. Now, I'm sure that everyone here is familiar with pictures of marine organisms being entangled and suffocating on marine debris, but they can also decrease the hatch rates, growth rates, and even suppress the alarm cues that many animals send out when in the presence of predators. Finally, plastics have a low density in comparison to seawater, which allows them to float and therefore be easily manipulated by the surface currents in our oceans. For example, this is a picture of the Exuma Sound, where we are currently sitting as a star here at the Island School. This area, given its basic geography, has been proposed to act as a sort of sink where plastic can enter and has the potential to easily accumulate in large numbers. With this, the main problem that our research hopes to address is the knowledge gap that exists on plastic pollution, specifically in the Exuma Sound. Furthermore, the specific research questions that we try to answer with this study are: 1, how much and what types of plastic are existent in the Exuma Sound? 2, what are their biological impacts? And 3, how do they enter the food web, where do they enter the food web, and how do they move throughout the food web?
To quantify plastic in the Exuma Sound, we use several methods, including plastic trawls. Using a boom that extends off the side of the boat, we drag a net along the surface of the water. As you can see in the photo, the boom holds the net outside of the disruption of the wake. We conduct the trawls for 15 minutes at about a speed of 5 knots, recording the start and end, latitude and longitude. When finished with the trawls, we pull in the net and collect the contents of the trawl into a test tube, storing it for later sorting in the lab. In the lab, we pour the contents of the trawl into a concentrated saltwater solution. This allows the lower density plastic to float while the biological material sinks to the bottom. We sort out the plastic by hand and identify it under a lab microscope. To collect fish in the Exuma Sound and discover whether or not there's plastic in their stomachs, we use a fishing aggregation device, or a FAD. This device provides shelter and shade, attracting smaller prey fish. Larger pelagic species like mahi-mahi and tuna, which we aim to catch, follow the small prey fish and congregate around the device. We fish around the device and collect its specimen for analysis and dissection in the lab. Lastly, we troll for pelagic fish in the Exuma Sound. We stand at the stern of the boat and have 3 rods out at a time. Unfortunately, it is not the season for the pelagic fish we aim to catch, and therefore they are very hard to catch. With the cooperation of local fishermen, we have collected several stomachs from them and have used them to add to our data. Here you see us dissecting a bonita tuna in search of microplastic and macroplastic within the stomach.
For our results, as you can see, this graph is showing the frequency on the y-axis and the size of plastic on the x-axis. And we're looking at our pelagic stomach data in the black bar and our trawl data with the gray bar. And we found that there was considerably more microplastic overall in both our stomach and trawl data. And we also found a consistent level of micro and macro plastics for each the stomach and the trawl data. This graph is showing the frequency on the y-axis of the different types of plastic on the x-axis. And we found that fragments were most abundant in the environment with 43%, and film being most abundant in the stomachs with 50%. Interestingly, we found a considerable difference with the amount of fragments found in the environment compared to the stomachs, and the amount of film found in the stomachs compared to the environment. We also found that styrofoam was least abundant overall with less than 1%. This graph is showing the frequency on the y-axis of the different colored plastics on the x-axis. We found that the majority of the plastic collected were clear in color overall, with 45% in the environment and 51% in the stomachs. We also found a near equal proportion of each colored plastics for both the stomach and the trawl data.
All right, so throughout our study, it has been seen that there is no considerable difference in the amount of plastics we have seen throughout these specific pelagic species. And as seen in this graph, where on the y-axis we have our average amount of plastic particles, which we are finding in these different pelagic species, stomachs, and on the x-axis we have our 5 specific species, which we are analyzing. And so there's a relatively consistent level of plastic, which we are finding in these species, ranging from an average of 0.4 plastic particles to about 1.1 plastic particles. Furthermore, when analyzing and comparing the amount of micro and macro particles, which are showing up in both the stomachs of fish and in the environment, we've come to believe that the degradation of macro plastics, or in other words, larger plastics, they're likely the cause of the greater increase of, or abundance of microplastics, which we have seen in the stomachs and in the environment, or marine food web. And in this photograph, we are measuring the particles which we found through conducting trawls and through sifting through pelagic species stomachs.
To explain the abundance of the clear and white plastics most commonly found in both the environment as well as the pelagic stomachs, we agree that there has been a mass production of both these colored plastics, which are then improperly disposed of in our oceans. Similarly, film and fragments have been most commonly found again in both the environment as well as the pelagic stomachs. However, film has been most commonly found in the pelagic stomachs, and we agree that this is due to the small prey fish misidentifying it as food. in this diagram, we see that plastics enter the food chain at the same time that animal plankton does, and it accumulates and rises until it reaches the pelagic fish in which we dissect and remove the plastic from. We also found a trend in our data, and that is that in all the pelagic fish stomachs that we have dissected, there has been a similar amount of plastics found, allowing us to believe that they have been feeding off similar food sources. Our research has led us to further believe that this is a relevant problem in both the Exuma Sound as well as the rest of the oceans, and there needs to be further research assessing both the behavioral and physiological effects of plastic ingestion by fish. We will also like to expand our research to cover reef fish, coastal species, trophic levels, deep sea, as well as the human impact because we intake these pelagic fish which do contain plastics. We'd like to acknowledge both our research advisors, Cameron Goose, as well as Dr. Travis Van Leeuwen, 5 Gyres, and the Cape Eleuthera Institute. We'll now open the floor for questions.
So, given that the amount of plastics in the troll water and the fish stomach are about the same, are you able to hypothesize if the bait fish or plastic fish are actually targeting plastic, or if it just happens to be that they're eating it in the water and they're really not trying to target it?
So the question was if we believe that the small prey fish choose to eat the plastic or just mistaking it for a food source. We believe that they have been mistaking it as a food source, and because the film that has been commonly found in the fish stomachs are clear and can be confused as plankton, which is their regular food source. So we do believe that this is just a mistake and they don't know that it's actually hurting them.
Any thoughts on plastic ingested by the fish, whether it's excreted or whether it becomes absorbed in their bodies?
So the question was if the plastics that are ingested by these fish are excreted or if the plastics are absorbed. And there are chemicals that are in these plastics which absorb into the fatty tissues of these fish, which, as Kit said earlier, affects their alarm cues, being able to know if predators are around, and so it absorbs and really affects these fish.
Military policy initiatives currently in the works in the Bahamas to try and regulate plastic pollution?
So the question is, have there been any regulations on plastic usage in the Bahamas? Currently, there are not very strong legislation acts against plastic use on the ocean. There are regulations on certain equipment to contain plastics, but as of right now, there are very few legislative acts against plastic usage.
Again, knowledge for 37 years. The plastic on the Atlantic side, a lot of it comes all the way from Haiti at the very least. Because I found that, it's proof in the bags that's written on it. The little plastic bags you find, those are water bags sold in Haiti. Made there, sold for 5 cents for 8 ounces of water. Kind of tons of them, right? Yeah, they're Haiti.
If for any of you who didn't hear her, she was just saying that a lot of the plastic has come from other areas. So she was saying that she's found plastic bags that with proof that came from Haiti. So plastic is coming from a bunch of different areas. Yeah.
In your literature search, did you learn anything about what's called the Great Ocean Plastic Dump in the North Pacific, which is a huge area where floating plastics aggregate in the North Pacific environment?
So if I'm not mistaken, the question is, in our literature that we read before this study, did we hear of the large plastic dumpage in the Atlantic? Is that correct? North Atlantic? North Pacific. From what I recall, we did not. One of the studies that we did read about suggested that most plastic accumulates in the North Subtropical Gyre, or North Atlantic Subtropical Gyre, and gyres being the major current systems in our oceans. But as I said before, I don't believe that we did read about that.